Physics. Pressure, pressure, pressure. F over A. What's this? Fish over aeroplane? Oh my god. Hey guys, come over here.
What's up?
I'm studying physics. About pressure. And I'm pressure of my mom, dad. With their expectations, with their big expectations. Oh my god.
Yeah, you seem to have lots of pressure right now.
Yes.
So, which topic you're studying right now?
Pressure.
Oh, there's a lot of pressure over there actually.
Yes.
Well, we just have finished our group discussion. Why don't we meet you? You gonna tell it to you or explain it to you?
Oh really?
Yeah. You want it?
Why not?
Yeah, sure. So, actually, pressure can come from external factors, but in physics, pressure is another thing. So, we can explain it to you.
Okay.
Why don't we go to somewhere else?
Okay.
You can do it.
Yeah, sure. Let's go.
Yes. Hi. Now today we're gonna discuss about pressure. Have you discussed with your friends? So now I'll discuss with you. Pressure is actually force per unit area. The formula of pressure is P equal to F over A. The SI unit of pressure is Newton per meter squared, or as known as Pascal. There are many applications in our life that includes pressure in it. For example, knife used for cutting. Second is high heels shoes and plate-based shoes. Third is tires in vehicle. Fourth is thumbtacks or nails. Now, I will show you a demonstration about pressure. So as you can see, there is a bottle in front of me, and the weight of the bottle is actually the water in it. As you can see, I'm putting the bottle onto my hand and I'm feeling something actually. The feel is actually pressure. The weight in the bottle is constant, but the surface area is different when it is on the top of the bottle, which is the lid, and the bottom of the bottle, which is the surface of the bottle. The pressure will be different when you put the surface on your hand and the lid onto your hand. back to the formula. P equals to F over A. Pressure is actually inversely proportional with area, because we assume that the force is constant. As you can see, when I put the surface of the bottle onto my hand, the surface area is larger, which means pressure is lower. But when I put the lid on my hand, the surface area is smaller. Hence, the pressure is higher. Now, discuss with your friends what pressure is and search around you, around your surroundings, what objects that produce pressure, which is high or low pressure. Okay, students, you have proof about pressure equals to force over area, right? What about a cool experiment? Do you know what the bed of nails? This is only a replica of it, but we're going to use it later. Now, we have 1, 2, and 3 nails. And of course, a replica of bed of nails. And some balloons. In this experiment, I want to prove it about how easily the balloon will pop when we use 1, 2, and 3 nails, and of course, a bed of nails. Look carefully when I use 1 nails only. The balloon pop easily. And how about 2 nails? Easily pop too. And 3 nails. Easy. Okay, now we're gonna use the replica of bed of nails. I'm gonna push the balloon onto the bed of nails and watch which it's gonna be pop easily or not. A lot of pressure needed. So students, discuss with your friends whether a bed of nails or 1, 2, and 3 nails are easier to pop the balloon, and why? Well, friends, actually bed of nails is not magic, not mysticism, it's only science.
So why does that kind of condition happens when we use 1, 2, or 3 nails? The balloon is easily being popped. But when we use a bed of nails, the balloon is hard to be popped out. So now let me explain to you that situation. So the formula of pressure states that pressure equals to force exerted over the surface area. So the relationship between the surface area and the pressure can be summarized as follows. So, as we can see, in the first experiment, we use small nails, which is small surface area. So with this small surface area, the pressure produced is high. But on the other hand, with the bed of nails, which involves large surface area, so the pressure produced will be high, hence making the balloon to be hard to be popped out. So another theory states that pressure is inversely proportional to the surface area exposed to the force when the force is constant. So let's say if I have a bottle of water, so the water in this bottle gives a weight which produces pressure. So as we can see that this bottle exerts a force towards its base area, which the base area is large. So the pressure produced will be low. But on the other hand, if I were to put the bottle upside down with the same force exerted towards the small surface area, the pressure produced will be high. So another theory states that pressure is directly proportional to the force exerted when the surface area is constant. Let's say if I have a box which its base area is constant and the force is exerted on the box. If the force is increased, the pressure produced will also increase. But you have to remember that the area should remain constant. So, from that experiment, 1, 2, or 3 thumbtacks used to pop the balloon will result in an easy pop balloon. Since the area is small, so the pressure produced is high. But with a bed of nails, the balloon will be hard to be popped up because the area of the nail is large, which results in the pressure produced will be low. So friends, I have explained to you the relationship of the surface area and the pressure produced. Now let's learn how to calculate pressure produced according to the formula. Friends, I have a question for you. With this question, we will learn how to calculate pressure according to the formula. Let's answer this question. On the table is a full box of groceries which has a weight of 160 Newton. The area of the base of the box is 0.2 meters squared. What is the pressure between the box and the tabletop? The diagram shows a bag with its padding. So the padding is labeled as X. What is the function of X?
Have you solved the answer with your friends? Now I will show you how to solve the problem. Students, we're going to solve question 1 first. Based on question 1, you need to take all of the information given on your paper. The first information given is weight. Weight is equals to force, and the information given is 160 Newton. The next information given is A, which means total surface area is 0.2 meter squared. Okay, based on the formula P equals to force over area, substitute the information given, which means 160 Newton over 0.2 meter squared. By using the calculator, you will get 800 Newton meter -2 or Pascal. Now we're going to move on with question 2. As you can see, question 2 is about a bag, and please do identify X, what it is first. Well, you know that X is actually a padding of a bag. The area of the padding is bigger than the string of the bag. So, when the area is higher, that means the pressure is lower, because pressure is inversely proportional to area. On the question stated, it asks you to state what is the function of X. This means the function of X is to lower the pressure as the area increases. Now students, why don't you do in groups to make an appropriate simple experiment in your own lab? I'll bet later.
So friends, have you designed a suitable experiment to study pressure? Now I'm going to suggest a suitable experiment to study the concept of pressure. So what we're going to need in this experiment are different areas of slotted weights, plasticine, a weight scale, and a ruler. So what we're going to do is we're going to put a constant force on the plasticine using different surface area of slotted weights. So using the smallest surface area of the slotted weight, so the constant force would be 5 kg, which is equal to 50 Newton. Okay, done with the first slotted weight. Now we're going to use a bigger surface area of slotted weight, applying the same constant force. Now we're going to use the biggest slotted weight. Same force is exerted to the slotted weight. Okay, done. We're going to compare the deepness of the patterns which have been formed by different area of slotted weights. So for the first slotted weight which we have been used, the smallest surface area, as we can see, it has the deepest pattern formed. Now moving on to the second slotted weight, which has a larger surface area. As we can see, the deepness of the pattern decreases. Moving to the biggest surface area of the slotted weight used. As we can see, the deepness is decreased significantly. So why does this happen? So as we can see, according to the theory, smaller surface area will produce higher pressure, hence producing large deep area of the pattern compared to this big surface area of slotted weight. So the big surface area will produce less pressure, which results in less deep pattern. So students and friends, from the experiment just now, I'm sure all of you have got a clearer picture on the concept of pressure. Now let's revise back. Pressure is the force unit per area, with the formula force per unit area. The standard unit for pressure is Pascal or Newton per meter square. So students, pressure is easy. With all the activities that have been done, I'm sure you can excel in this topic.
Hey, I got the news that you got A for physics, is it true?
Yeah, thank God I managed to get an A in physics.
Oh, congratulations.
Thank you.
Hey guys,
Yay.
guess what? I got an A for my physics examination.
Wow, me too.
Yeah, thanks a lot for teaching me before.
Oh.
And guess what? Now I know about pressure. It's not fish over aeroplane, right?
No.
Alright, force over area, right?
Yeah.
And there's a unit for pressure is Pascal, right? Yeah. And once again, thanks a lot.
Yeah.
Now, no pressure again.